Welcome to Study Loop.
So in this problem, a needle is performing a simple harmonic motion whose frequency is 2.5 Hz given in the problem, and the initial displacement and initial velocities are also given at t equal to 0. So you can see in this picture, needle could go in a negative x direction or positive x direction while performing a simple harmonic motion. So this problem has two parts. In the first part, it is asking us to calculate the acceleration at t equal to 0. So to do this, what we can do is just writing the equations for the position as a function of time, which is a cosine of omega t plus phi. And for the acceleration, it is negative omega square a cosine of omega t plus phi. So these equations are already given in the book. If we combine these two equations, we can write it as a function of time as negative omega squared x as a function of time. So this is already given in the data, which is 1.1 10 to the power -2 meters. And to calculate this omega, what we can do is to write as 2 pi f, and if we use this f in this, we can easily calculate it as 15.7 radian per second. So now we can combine these two to calculate this acceleration at t equal to 0. So let's move on. So now we can write as a at t equal to 0 as 15.7 radians per second with square over into 1.1 10 to the power -2 meters. And now if we multiply these two numbers, we can easily write it as negative 2.17 meters per second squared. So this is the first part, and in the second part, they are asking us to calculate or write the equations for position, velocity, and acceleration using the data we already have calculated. So to do this, if we see this equation, we need, if we see this equation on the first page, we need amplitude and the phase angle to write the equations for position, velocity, and acceleration in terms of the data we have. So to do this, we will start calculating the amplitude, which can be written as this over omega squared. So this is already good in the book. Again, this is just the plugging numbers in. If you plug the numbers in, you can easily calculate it. Centimeter, or in terms of meters, we can write it as this. And similarly for the phase angle, the formula for the phase angle is arc of negative of velocity d of the x component over this. So again, this is just plugging numbers in. If you plug the numbers in correctly, you can easily calculate it as this. So now we can use this a, phi, and the data we already have calculated to write the equations they are asking us to write. So then we can easily write x as a function of time with 1.4 10 to the power -2 meters cosine of 15.7 radians per second into time plus the phase angle, which is 0.715 radians. So similarly, we can write it for velocity, which is negative 1.46 10 to the power 2, and then the angular frequency you can easily calculate velocity from position by just taking the derivative and then just plug the numbers in what we already have. And for the acceleration, we can clearly just writing same thing again and again. And make sure the dimension in the equation are consistent. And if you want to check whether this is consistent, you can see that argument of the cosine or sine should be dimensionless. So these are the three equations they want us to write, and if you want to check whether you have calculated it correctly, you can check the position and velocity at t equal to 0, and they should give the same x naught and v naught. V naught x, which is already given in the question. Thank you.